During your calculus courses, you'll be given some functions that you need to find the derivative of. But sometimes there'll be composite functions. There'll be composite functions of f of g of x. So to find the derivative of this composite function that we're given, f of x and g of x both need to fit some criteria. Let's start with g of x. G of x needs to be differentiable at whatever value x that is given, and then f of x needs to be differentiable at our function value g of x. So if these two are true, then we can use our chain rule. So the chain rule just says at our composite function f of x, that the f prime of x is going to be equal to the derivative of our first f of x at the function value g of x multiplied by the derivative of g of x. And if we use Leibniz notation, that will just be the same thing as saying dy dx is equal to dy du times du dx. And that's if y is equal to f of u and u is equal to g of x. And just to help us remember how the chain rule works, it works from the outside to the inside. So we go from outside to inside always with the chain rule. So let's say the derivative of f of x, or derivative of f of g of x, is equal to the outside derivative times the inside, or evaluated at the inside, times the derivative of the inside. So let's just say we go from out, this is the outermost, and then it goes from the inside, and again outside. Inside stays the same for the derivative, and then we move closer to the inside by multiplying by the derivative of the inside function. So that's just a little way to make it easier to remember. So let's look at the function square root of x squared plus 4. In order to find the composite function of f of g of x, we need to first see which two functions we're using for our f and our g of x. So on our inside, we have our function x squared plus 4. And then our outside function will just be the square root of x. So as you can see, if we replace this x here with this, we're going to get our original function. So using that logic, we can say our f of x is equal to the square root of x, and our g of x is equal to x squared plus 4. So let's write our chain rule again. So we'll have the derivative of our f of x evaluated at g of x multiplied by the derivative of g of x. So let's just work linearly. We'll have f of x is equal to square root of x if we take its derivative, so the derivative of f of x. Let's see. We'll have x to the 1/2 power, and we use our power rule to get 1/2 x. 1/2 x to the negative 1/2 power. And rewriting that, we'll have 1 over 2 square root x. If we take our derivative of our bottom function, g of x, we'll get 2x plus 0, because 4 does not have any x value. So when we derive it, it just goes to 0, and using the power rule for 2x. So we're left with these two functions, so f prime of x, and this one is g prime of x. So just plugging everything in with our little formula that we have here, we'll have f prime of x evaluated at g of x first. So we'll have 1 over 2 of the square root. Now we're not going to put x here, because we need to put it evaluated at g of x. And our g of x is equal to x squared plus 4. So x squared plus 4, all multiplied by the derivative of g of x, which is 2x. We can simplify this further to have 2x over 2 of the square root of x squared plus 4. And then our 2's will simplify. So we're just left off with x over the square root of x squared plus 4. And that is the derivative of our function x squared plus 4.